The most distant human-made object, NASA's Voyager 1 spacecraft, is in interstellar space, the space between the stars.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Did anyone expect for Voyager 1 to stay up there, in outer space, traveling in both darkness and light, and outlived its life expectancy? That's a monumental feat alone, but continuously discovering new things is a different story. After almost 5 decades, Voyager 1 is still perfectly working for the entire humankind, and what you're about to learn will leave you breathless. Lost for a moment. Considering its old age, Voyager 1 has its own technical challenges and limitations. One of those is its consistent ability to just be perfectly available out there. It slept for 5 long Earth months, and after 5 months, it's back to work for the experts, an almost impossible thing to do. In the realm of space exploration, NASA's Voyager 1 stands as a beacon of human ingenuity, perseverance, and curiosity. Launched in 1977, the spacecraft has journeyed farther than any human-made object, currently residing in interstellar space. However, even this extraordinary mission has faced challenges, one of the most significant being the temporary loss of connection in late 2023. This hiatus underscored the complexities of managing a spacecraft billions of miles away, while reaffirming the dedication of the team supporting it. In November 2023, Voyager 1 experienced a technical anomaly that disrupted its ability to send coherent data back to Earth. The spacecraft, approximately 15 billion miles away, relies on systems designed over 4 decades ago, making troubleshooting particularly challenging. Signals from Voyager 1 take over 22 hours to reach Earth, complicating real-time communication. The disruption was traced to a defective component within the spacecraft's communication systems, which led to the transmission of indecipherable data. This setback temporarily halted its ability to send updates about its condition and scientific observations. Restoring Voyager 1's connection required ingenuity and persistence from NASA engineers. Despite the spacecraft's age and the immense distance, the team worked tirelessly to identify the problem and devise a solution. By March 2024, they successfully reprogrammed Voyager 1's systems to bypass the faulty chip, restoring its ability to communicate with Earth. This achievement highlighted not only the robustness of the spacecraft's design, but also the expertise of the mission team in adapting to unforeseen challenges. Is the hiatus important? The temporary loss of communication with Voyager 1 served as a reminder of the difficulties inherent in long-term space exploration. Operating a spacecraft with limited power and outdated technology in the harsh environment of interstellar space is no small feat. Yet, the successful restoration of contact demonstrated the resilience of the mission and the commitment of the scientific community to extend its lifespan. With communication restored, Voyager 1 continues its mission of exploring the interstellar medium, providing invaluable data about the environment beyond our solar system. While the spacecraft's power supply is gradually diminishing, the mission team remains optimistic about its ability to operate into the late 20s. The lessons learned from this hiatus will undoubtedly inform future interstellar missions, ensuring that the legacy of Voyager 1 endures. In overcoming this challenge, Voyager 1 has once again proven its status as a symbol of human ingenuity, a testament to our desire to explore the unknown, and a reminder of the enduring spirit of discovery that drives space exploration. Let's make a recap of all of Voyager 1 discoveries and contributions in space exploration. Voyager 1, recent discovery. We can't be familiar with everything, so let's make a brief and simple introduction of terms. The word interstellar means between the stars. It refers to the vast space that exists outside our solar system, but still within our galaxy, the Milky Way. This space is mostly empty, but it contains very thinly spread gas, dust, and particles like plasma. It's the region where the sun's influence fades, and the environment is shaped by the stars and the galaxy itself. For example, when scientists say that Voyager 1 has entered interstellar space, they mean it has traveled beyond the protective bubble created by the sun, called the heliosphere, and is now in the space between the stars. Since its historic launch in 1977, NASA's Voyager 1 spacecraft has served as a pioneer in space exploration, offering unprecedented insights into the cosmos. Now traversing interstellar space, Voyager 1 continues to provide groundbreaking data, particularly about plasma density, a fundamental property of the interstellar medium. These discoveries have significant implications for our understanding of the universe and our place within it. Plasma, the fourth state of matter, consists of charged particles such as electrons and ions. In the context of interstellar space, plasma density refers to the number of these particles per unit volume. Measuring this density is critical to understanding the physical properties of the interstellar medium, including its turbulence, temperature, and interaction with the heliosphere, the protective bubble formed by the solar wind around our solar system. Voyager 1's data on plasma density help scientists map the transition from the heliosphere to interstellar space, shedding light on how the sun's influence diminishes and the true nature of the interstellar environment. One of the key instruments enabling these discoveries is Voyager 1's plasma wave system. By detecting oscillations in the surrounding plasma, the instrument measures the density and characteristics of the interstellar medium. Notably, after crossing the heliopause in 2012, the boundary where the solar wind gives way to interstellar space, Voyager 1 recorded an increase in plasma density, confirming its entry into a new cosmic frontier. Recent measurements have revealed density fluctuations in the interstellar medium, offering clues about the dynamic processes shaping this seemingly empty expanse. These findings indicate that the interstellar medium is more structured and turbulent than previously believed. The insights provided by Voyager 1's plasma density measurements have far-reaching implications. They improve our understanding of cosmic phenomena such as stellar winds, magnetic fields, and the life cycle of stars. By characterizing the interstellar medium, scientists can refine models of galactic evolution and better predict how interstellar conditions might affect future space missions. Moreover, studying plasma density in interstellar space deepens our understanding of the heliosphere's role as a protective barrier. As the sun's influence wanes, Voyager 1's data reveal how cosmic rays and other high-energy particles interact with the heliosphere, informing our knowledge of radiation environments in space. Voyager 1's journey through interstellar space is not without challenges. Operating at a distance of over 15 billion miles from Earth, the spacecraft relies on aging technology and a diminishing power supply. Despite these limitations, its continued transmission of valuable data underscores the resilience of the mission and the ingenuity of the team supporting it. Looking ahead, Voyager 1's plasma measurements will contribute to a more comprehensive understanding of the universe's vast expanse. As the spacecraft ventures further into interstellar space, it will likely encounter new phenomena, pushing the boundaries of human knowledge. By unraveling the mysteries of the interstellar medium, the spacecraft not only enhances our scientific understanding, but also inspires a deeper appreciation for the universe's complexity and beauty. In its continued journey, Voyager 1 remains a testament to human curiosity and the relentless pursuit of knowledge. All Voyager 1 discoveries. Launched on September 5, 1977, Voyager 1 has become one of humanity's most remarkable achievements in space exploration. Its primary mission was to study the outer planets of our solar system, but it has since ventured into interstellar space, making groundbreaking discoveries that continue to reshape our understanding of the cosmos. Thanks to this spacecraft, we knew about the enormous planet, Jupiter. Voyager 1's first significant milestone was its encounter with Jupiter in March 1979. The spacecraft captured stunning images of the planet and its moons, revealing unprecedented details about its atmosphere, magnetosphere, and moons. Among its most notable findings were the discovery of active volcanism on Io, one of Jupiter's moons, marking the first time volcanic activity was observed beyond Earth. It also revealed Europa's smooth, icy surface, sparking speculation about subsurface oceans that might harbor life. Additionally, Voyager 1 provided detailed images of Jupiter's Great Red Spot, a massive storm system, and mapped the planet's faint ring system. In November 1980, Voyager 1 reached Saturn, delivering new insights into the planet and its complex ring system. The spacecraft captured detailed images of Saturn's rings, revealing intricate structures such as radial spokes and wave-like patterns caused by gravitational interactions with the planet's moons. It also provided close-up views of Saturn's largest moon, Titan, which revealed a thick atmosphere composed primarily of nitrogen and methane. This discovery suggested the possibility of organic chemistry on Titan, laying the groundwork for future missions like Cassini-Huygens. After its planetary encounters, Voyager 1 embarked on its interstellar mission, continuing to send data from beyond the solar system. In August 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the solar wind gives way to the interstellar medium. This milestone marked its entry into interstellar space, where it began studying the plasma density, magnetic fields, and cosmic rays of this new environment. One of its key discoveries in interstellar space was the measurement of plasma density, which revealed that the interstellar medium is denser than the outer regions of the heliosphere. This finding has helped scientists better understand the interaction between the Sun's influence and the broader galaxy. Voyager 1 has provided invaluable data on cosmic rays, high-energy particles originating from outside our solar system. It detected an increase in cosmic ray intensity upon crossing the heliopause, confirming its entry into interstellar space. Additionally, Voyager 1's magnetometer has been instrumental in studying the magnetic field in interstellar space, offering insights into how these fields influence cosmic ray movement and the structure of the interstellar medium. While not a scientific discovery, Voyager 1's golden record deserves mention for its cultural significance. This time capsule contains sounds, images, and messages representing the diversity of life and culture on Earth. As Voyager 1 continues its journey through the galaxy, the golden record serves as a symbolic gesture of humanity's desire to connect with the universe. Even after more than 45 years in space, Voyager 1 continues to make valuable contributions to science. Its instruments, though aging, still function well enough to transmit data about the interstellar environment. These ongoing measurements provide a unique perspective on a region of space that remains largely unexplored. Voyager 1's discoveries have had profound implications for planetary science, astrophysics, and our understanding of the universe. Its journey has inspired generations of scientists, engineers, and dreamers, proving that human curiosity knows no bounds. The discoveries made by Voyager 1 represent some of the most significant achievements in the history of space exploration. From revealing the volcanic activity on Io to venturing into interstellar space, the spacecraft has expanded our knowledge of the solar system and beyond. As Voyager 1 continues its silent journey through the cosmos, it stands as a testament to humanity's enduring quest to explore the unknown and uncover the mysteries of the universe. 2 pioneering spacecrafts. By comparing the data from Voyager 1 and Voyager 2, scientists have been able to gain a more comprehensive understanding of the solar system's boundary. For instance, while both spacecraft crossed the heliopause, the conditions they encountered were slightly different, highlighting the asymmetric shape of the heliosphere. These differences suggest that the heliosphere is influenced by external factors, such as the local interstellar magnetic field and pressure. Voyager 1 and Voyager 2 are among the most extraordinary achievements in space exploration, launched by NASA in 1977 to study the outer planets and beyond. Although they were built with nearly identical designs and shared similar missions, the two spacecraft followed different trajectories and encountered unique discoveries along their journeys. We will unfold the similarities and differences between Voyager 1 and Voyager 2, highlighting their complementary roles in expanding humanity's understanding of the solar system and interstellar space. Both Voyager 1 and Voyager 2 were launched in 1977 as part of NASA's ambitious Voyager program. Voyager 2 launched first on August 20th, followed by Voyager 1 on September 5th. Despite its later launch, Voyager 1 was placed on a faster trajectory, allowing it to reach its planetary targets before Voyager 2. Both spacecraft were designed to take advantage of a rare alignment of the outer planets, which occurs roughly every 176 years, enabling them to visit multiple planets using gravitational slingshots. Voyager 1 focused on Jupiter and Saturn, providing groundbreaking data and images of these gas giants and their moons. One of its most famous discoveries was the detailed observation of Jupiter's Great Red Spot and the active volcanoes on its moon Io, the first evidence of volcanic activity beyond Earth. At Saturn, Voyager 1 studied the planet's intricate ring system and its largest moon, Titan, whose dense atmosphere was of great scientific interest. Voyager 2 had a more extended planetary mission, visiting not only Jupiter and Saturn, but also Uranus and Neptune, becoming the only spacecraft to date to study these ice giants up close. Voyager 2 revealed Uranus's tilted magnetic field and discovered 10 new moons. At Neptune, it captured stunning images of the planet's deep blue atmosphere and detected the fastest winds in the solar system. After completing its flybys of Jupiter and Saturn, Voyager 1 was directed upward, out of the plane of the solar system, to study the interstellar medium. In contrast, Voyager 2 continued on its path through the plane of the solar system to explore Uranus and Neptune. These differing trajectories allowed the two spacecraft to provide complementary perspectives on the outer solar system and beyond. Both spacecraft eventually crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. Voyager 1 crossed the heliopause first, in August 2012, becoming the first human-made object to enter interstellar space. It detected a dramatic drop in solar wind particles and an increase in cosmic rays, confirming its exit from the heliosphere. Voyager 2 followed in November 2018. Unlike Voyager 1, Voyager 2's plasma instrument was still functional at the time, allowing it to provide direct measurements of plasma density. This gave scientists more detailed information about the transition from the solar wind to the interstellar medium. Both Voyager spacecraft carry the same suite of instruments, including cameras, plasma detectors, and magnetometers. However, the functioning of these instruments differed over time. Voyager 1 had its cameras turned off after its planetary mission to conserve power for its other instruments. This meant it did not capture images of its journey through interstellar space. Voyager 2, with its plasma instrument operational during its heliopause crossing, provided critical data about the density and temperature of interstellar plasma, which Voyager 1 could not measure directly. The Golden Records. Both spacecraft carry the Golden Records, phonograph records containing sounds and images that represent the diversity of life and culture on Earth. These records were designed as a time capsule, intended to communicate with any extraterrestrial life that might encounter the spacecraft. While both records are identical, they symbolize humanity's hope and curiosity for making connections beyond our solar system. Together, Voyager 1 and Voyager 2 have transformed our understanding of the solar system and interstellar space. Their data have contributed to numerous scientific discoveries, from the dynamics of planetary atmospheres to the structure of the heliosphere. They also serve as symbols of human ingenuity and the spirit of exploration, continuing to operate far beyond their expected lifespans. Voyager 1 and Voyager 2 are twin spacecraft that have taken different paths, but share the same mission of exploring the cosmos. While Voyager 1 was the first to enter interstellar space, Voyager 2's extended planetary mission and functional plasma instrument have provided unique insights into the outer planets and the boundary between the solar system and interstellar space. Together, they have offered humanity a deeper understanding of our place in the universe, inspiring generations of scientists and explorers to continue reaching for the stars. Its life expectancy. Voyager 1, launched in 1977, is humanity's most distant spacecraft and a remarkable testament to engineering and exploration. After more than 4 decades in space, the spacecraft continues to send data back to Earth, but its mission is inevitably approaching its conclusion. Understanding how long Voyager 1 will last requires considering factors like its power supply, instrument functionality, and the challenges of operating in deep space. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, which convert heat from the decay of plutonium-238 into electricity. When it was launched, these RTGs generated about 470 watts of power. However, the energy output decreases by about 4 watts per year as the plutonium decays. As of 2025, Voyager 1 has about 250 watts of power remaining, and mission engineers have been systematically shutting down non-essential systems to conserve energy for critical instruments. NASA estimates that Voyager 1 will lose the ability to power its scientific instruments by the early 2030, likely marking the end of its ability to collect and transmit meaningful data. Voyager 1 carries several scientific instruments designed to study the interstellar environment, including its plasma wave subsystem, magnetometer, and cosmic ray detector. Despite their age, many of these instruments are still functioning and providing valuable data. However, as the power supply dwindles, these instruments will be gradually turned off to prioritize essential systems like communication. Even if power were not an issue, the wear and tear from decades of operation in the harsh environment of space would eventually render the instruments less reliable. Voyager 1 communicates with Earth using the Deep Space Network, a system of large radio antennas. Given its immense distance, currently over 15 billion miles, 24 billion kilometers from Earth, signals take more than 22 hours to travel each way. Maintaining communication requires precise alignment and robust technology. But as the spacecraft continues to drift farther, the signal strength will weaken, and communication will eventually become impossible. Even after Voyager 1's instruments and communication systems cease to function, the spacecraft will continue its journey through interstellar space, traveling at about 38,000 miles per hour, 61,000 kilometers per hour. Voyager 1 will remain a silent ambassador of Earth, carrying its golden record, a time capsule of sounds, music, and images representing humanity, intended for any intelligent life it might encounter. Over the next tens of thousands of years, Voyager 1 will pass relatively close to other stars, such as Gliese 445, approximately 40,000 years from now. While it will no longer be operational, its journey will continue, symbolizing human curiosity and exploration. Voyager 1 is nearing the end of its operational life, with its power supply expected to run out in the early 2030. Despite this inevitable conclusion, its contributions to science and its symbolic value will endure far beyond its active years. As it ventures deeper into interstellar space, Voyager 1 will remain a beacon of humanity's desire to explore the unknown and reach for the stars. The need for space exploration. The question of whether Voyager 1 and other spacecraft are worth the investment is a complex one, touching on scientific discovery, technological innovation, cultural significance, and financial cost. Space exploration programs like NASA's Voyager missions have significantly advanced our understanding of the universe, but they also come with substantial costs and logistical challenges. This section explores the value of these missions, weighing their benefits against their costs. One of the strongest arguments in favor of spacecraft like Voyager 1 is the unparalleled scientific knowledge they provide. Voyager 1, for instance, has revolutionized our understanding of the solar system and beyond. It captured detailed images of Jupiter and Saturn, revealing active volcanoes on Io and the thick atmosphere of Titan. Its journey into interstellar space has offered groundbreaking data on plasma density, cosmic rays, and magnetic fields in the interstellar medium. Beyond Voyager, missions like the Mars rovers and the James Webb Space Telescope have answered fundamental questions about planetary geology, atmospheric conditions, and the origins of the universe. These discoveries deepen humanity's understanding of our place in the cosmos and pave the way for future exploration and innovation. Spacecraft development drives technological advancements that benefit other industries. The challenges of space exploration often lead to breakthroughs in engineering, materials science, and communication technology. For example, innovations in robotics, imaging systems, and artificial intelligence have applications in fields such as healthcare, transportation, and telecommunications. Space programs also stimulate economic growth by creating high-tech jobs and fostering collaborations between governments, private companies, and academic institutions. The commercial space sector, including companies like SpaceX and Blue Origin, has grown significantly, partly due to the foundational knowledge gained from earlier missions like Voyager. Spacecraft like Voyager 1 have immense cultural and inspirational value. The golden record aboard Voyager 1 is a poignant symbol of humanity's curiosity and desire to connect with the universe. Images like the pale blue dot, captured by Voyager 1 as it looked back at Earth, remind us of the fragility and unity of life on our planet. These missions inspire people around the world, encouraging the pursuit of science, technology, engineering, and mathematics, STEM, careers. They foster a sense of global collaboration and wonder, showing what humanity can achieve when united by a common goal. Critics argue that the high costs of space exploration could be better spent addressing urgent problems on Earth, such as poverty, healthcare, and climate change. Space missions require billions of dollars, and their benefits, while significant, may not be immediately tangible to the average person. However, proponents counter that the funds allocated to space exploration are relatively small compared to other expenditures, such as defense budgets. Additionally, the long-term benefits of scientific discovery and technological innovation often outweigh the initial investment. What do we expect in the next As humanity faces global challenges like climate change and resource scarcity, space exploration offers potential solutions. Studying other planets could provide insights into Earth's climate systems, while asteroid mining could address resource shortages. Missions like Voyager 1 demonstrate humanity's ability to reach beyond current limitations, laying the groundwork for future exploration of the Moon, Mars, and beyond. The development of reusable rockets and advancements in space technology are also making space exploration more cost-effective, further justifying the investment. Voyager 1 and other spacecraft are undoubtedly worth the investment, given their contributions to scientific discovery, technological innovation, and cultural inspiration. While space exploration comes with high costs, its long-term benefits far outweigh these challenges. By pushing the boundaries of what is possible, missions like Voyager 1 remind us of humanity's potential to explore, innovate, and dream on a cosmic scale. These endeavors are not just about reaching the stars, they are about understanding our own existence and ensuring a brighter future for generations to come. Meaning of life. Through Voyager 1. Exploration. Since its launch in 1977, Voyager 1 has become more than just a spacecraft. It is a symbol of humanity's quest to understand the universe and our place within it. While its primary mission was to explore the outer planets, Voyager 1 has taken on a profound philosophical role as it ventures into interstellar space, carrying with it humanity's curiosity and the hope of finding answers to the most fundamental question: what is the meaning of life in the universe? Voyager 1's scientific discoveries have provided humanity with an expanded understanding of the cosmos. From its close-up images of Jupiter and Saturn to its measurements of interstellar plasma, the spacecraft has offered insights into the conditions that shape planetary systems and the vast, unexplored interstellar medium. These discoveries provoke deeper questions. Is life unique to Earth, or is it a universal phenomenon? By studying the environments of moons like Europa, which may harbor subsurface oceans, Voyager 1 laid the groundwork for the search for extraterrestrial life. Such missions challenge the anthropocentric view of the universe, suggesting that life could arise in conditions vastly different from those on Earth. This possibility has profound implications for how humanity perceives its role in the cosmic order. Voyager 1's golden record embodies humanity's hope of making a connection with intelligent life elsewhere in the universe. The record contains sounds, images, and greetings from Earth, showcasing the diversity of life and culture on our planet. Its inclusion in the Voyager mission reflects a profound belief that the search for meaning extends beyond scientific discovery to a desire for communication and understanding. The golden record symbolizes a universal yearning for significance. If an alien civilization were to discover Voyager 1, it would serve as evidence that humanity once existed and sought to share its experiences and aspirations. This act of sending a message to the cosmos highlights the deeply human need to leave a legacy and find purpose beyond our immediate existence. One of Voyager 1's most iconic contributions is the pale blue dot photograph, taken at Carl Sagan's suggestion, as the spacecraft looked back at Earth from a distance of 3.7 billion miles. This image captures Earth as a tiny speck suspended in the vastness of space, underscoring the fragility and uniqueness of life on our planet. Sagan's reflection on the image emphasized the unity of humanity and the need to cherish our shared home. The photograph serves as a reminder that the search for meaning is not just about discovering life elsewhere, but also about recognizing the value of life on Earth. It challenges humanity to look inward and strive for greater compassion, cooperation, and stewardship of our planet. As Voyager 1 travels deeper into interstellar space, it continues to explore uncharted territory, symbolizing humanity's relentless pursuit of knowledge. Its journey raises questions about the ultimate purpose of exploration. Are we searching for evidence of life elsewhere to validate our own existence? Or are we driven by an innate curiosity to understand the universe, regardless of whether it holds answers to the meaning of life? Voyager 1's mission highlights the interplay between science and philosophy. While its instruments measure physical phenomena, its journey inspires metaphysical contemplation. It represents a bridge between the tangible and the transcendent, offering a framework for considering humanity's place in the cosmos. Voyager 1's exploration of the universe is not just a scientific endeavor, but a deeply philosophical one. Its discoveries, the golden record, and the pale blue dot image all contribute to humanity's ongoing search for meaning in the vastness of space. As it ventures further into interstellar space, Voyager 1 reminds us that the quest to understand life's purpose is both a scientific and a spiritual journey. It challenges us to look beyond our immediate surroundings, to cherish the life we know, and to continue seeking answers to the mysteries of existence. In doing so, Voyager 1 becomes more than a spacecraft. It becomes a symbol of humanity's enduring hope and boundless curiosity. That's the end of the video. Thanks for watching, and we'll see you in the next space content.